Thanks everyone for tuning in today. We're really glad to have you here. We're diving into how you can get sight precision without the hefty price tag. Yeah, it's possible, and we're here to show you how. So I'll start off with my details. Hi, Brad. I've been here with the company for a couple of years now, and I thought I'd just allow you guys to just take a moment if you wanted to scan my QR code there, download my details, and get in touch with me at any time. Quick breakdown on the company. So before we get stuck into the tech, I wanted to take a moment to clear up a question that I often get asked about the relationship between Mangoesmapping and MapGear. As you can see, that's the MapGear logo behind us with our 3 receivers. So Mangoesmapping is our full service company. So we provide bespoke solutions and deliver customized training and can provide quotes to very specified applications within your workflows. MapGear is an online e-commerce platform where you can basically go online 24/7 and buy anything that's live on there. So what we're going to look at today is how to achieve centimeter level accuracy with Emlid and how to choose the right tool for your requirements. We're going to have a look at the drone and sensor integration along with our real world case studies and customer workflows that we've actually got a couple of presenters coming on board today to show you how they do it as well. So starting off with what is GNSS? So GNSS, Global Navigation Satellite System, is a network of satellites that provide positioning, navigation, and timing data to receivers anywhere on the planet. So Emlid receivers consume all the listed constellations, including GPS, GLONASS, Galileo, and Beidou. How do we get centimeter accuracy on the Earth? Well, GNSS receivers also have the ability to receive a correction from a base established at a known point, as you can see here between the base and rover. This way we can reduce positional uncertainties down to just a few centimeters. Corrections can also be delivered in 2 ways. So via radio communication between the base and rover, as mentioned in the last slide, but also, which is becoming increasingly common, the internet-based corrections via NTRIP. So SmartNet, OzCores, and even Emlid Caster, which also, between the 3 of them, require mobile coverage at each end. So as you saw behind me earlier, here's a picture of all of our 3 receivers. The Reach RX is our baby. So let's have a look at the most basic centimeter receiver that we have. So this is an NTRIP only receiver, which means it only consumes RTK corrections over the mobile internet. So the corrections can be from existing services such as SmartNet, but it's also possible to establish your own base or of a known point or mark and send corrections via the internet to your receiver using Emlid Caster, which is also, believe it or not, free service from Emlid. It's easy to connect and it's really fast to do so. Basically, we've designed it so that it's so fast and easy. It's just as easy as connecting your iPods, your iPhone AirPods, or other Bluetooth devices in your home. Position streaming allows you to publish real-time positioning via the Bluetooth over NMEA streams from third-party apps like GIS survey and engineering apps such as 12D Field, Field Genius, and Carson's Serve PC. So here you can see that Reach RX is a really simple and value-packed solution to support surveyors and, importantly, non-surveyors. It helps them to confidently and consistently make measurements in the field for data collection and set out. So interestingly, when paired with our Emlid survey pole, it only weighs less than 1 kilo. And you can see here in this diagram, the receiver, the survey pole I was just mentioning, which is collapsible. So in this example, a surveyor, our own Andrew Cleland, is generating a centimeter accurate 3D model in just moments to create an accurate as constructed record of underground services. In this case, he's using Pix4D Catch app, which makes the scanning simple, uses the Reach RX to inject RTK accurate coordinates into the entire model. Along with Pix4D, it technically processes in the cloud, meaning your 3D model, cloud and mesh, can be completed already for you when you're back in the office. The Reach RS2, we've had this one for a few years now, but it can be configured as the base or a rover. So using the integrated radio that it also has, it allows you to achieve centimeter level accuracy in any rural offline setting, and also allows the use of a base and rover configuration like we mentioned earlier as well. So here is where it transmits corrections to the rover via the integrated LoRa radio. So static logging as well. Its capabilities allows users to log raw data on a base station, which is commonly used to coordinate new marks in an unknown location. The internal battery supports 22 hours of continuous raw data logging. And if you're interested in using Emlid for static, scan that QR code that's there as well. You can see one of our clients, Dale Atkinson, a cadastral surveyor, talk about his experience using Emlid for static. The RS2 Plus with the internal battery also charges by USB-C. So it's versatile and can charge anywhere. And the high capacity battery allows users to work all day with no battery swaps. Here we'll see our employee ergotam with some of our fleet. So RTK and PPK capability also allows the RS2 Plus to be used as a drone base station, as you can see. So with RTK to drone, an option even in offline areas using local NTRIP via Wi-Fi, it's a breeze. So the Reach RS2 can also be used as an RTK or PPK based for remotely piloted and autonomous survey vehicles. It's a great RTK rover for collecting ground and control points as well. So as you can see here, we've got it as a base and rover. So a base for the bathymetry boat as a rover. Now to the Reach RS3. I think it's probably our most popular unit because it's got the tilt compensation with the inbuilt IMU, but it has all the same features as the RS2 Plus as well. And a couple of extra capabilities like the tilt that I'll explain. So tilt compensation allows points of collection in otherwise obstructed or hard to reach places such as the corner of a building, under an overhang, or on the edge of a cliff drop off. The time saved not leveling the pole for every shot boosts productivity immensely and minimizes worker fatigue. So here we can see, again, our famous ergotam showing how the RS3 can be used in a precarious situation and still get the accuracy you need. So again, it has an internal battery that will run all day, along with the integrated LoRa 915 megahertz and UHF 450 megahertz radio for local transmitting and receiving of RTK corrections. You can use that without mobile internet as well within that context. And it's a powerful tool for accuracy offline. But the real point of difference for the RS3 that I wanted to share here is the integrated 450 UHF radio. So the internal UHF radio can consume only trim torque 450 corrections, which allows the RS3 to receive corrections from other GNSS brands and integrate into sites where an existing base might be established and broadcasting corrections via UHF radio. While the trim torque protocol is proprietary, it's widely supported by most radios and makes it easier for the Reach RS3 to work with any third-party base when using an external radio. The main point here is that every RS3 has tilt compensation working out of the box, and you won't be asked to pay for an activation code to unlock this feature. Another great thing about Emlid Flow, the software. So you've got Emlid Flow, which is the app for your phone, Android or Apple. And then you've got Emlid Flow 360, which is and allows you to install on your desktop. And if you're logged in the field and you're logged in the office, you can actually update and see what's going on in live time streaming. So as you can see, Emlid Flow is a free version, like I said, on an app and allows basic point data collection and stakeout and supports local Australian datums and geoids. But it also supports raw data logging and provides an easy export of survey outcomes into a variety of different commonly used file formats. And it also syncs to the cloud to allow you to sync your projects across multiple devices and directly to your desktop web browser. Let's talk about more on that now. So as you can see, the app is on the free level, has all of those options, but survey is an extra. It's only $375 a year. You get everything from the app for free, but also allows you to get all those extra survey level features that you might need, including map layers, CAD drawings, which is a new addition that's been really exciting, and extra survey codes. They're always making changes. They're always making upgrades. So, it's a watch this space situation. As I mentioned, adding CAD files into the Emlid Flow gives field crews instant access to the design layouts and making stakeouts faster, clearer, and more accurate. It's a really exciting feature that I know that a lot of people have been waiting for. A quick summary on these three amazing units. So the Reach RX, definitely a rover only as it's NTRIP based. RS2 and RS3 can be used either or as a base and rover. They're not locked out accordingly. As you can see, the base and rover situations within RS2 and RS3 have built-in LoRa. The RS3 has UHF frequency as well. The RX, again, NTRIP only. Tilt compensation is only available in the RS3. Battery life, again, very similar, and the price speaks for itself. So for $31.99 for the RX, $38.99 for the RS2 Plus, and RS3, again, very popular at $47.99. So here I'm just going to go quickly through some third-party integrations. For instance, as I mentioned before, we have a partnership with Pix4D that allows you to do reality capture, LiDAR scanning, importing of CAD designs, DXFs, and being able to view them in real time. It's an amazing little feature. Here we can see some other workflows where we've got ground penetrating radar, you've got bathymetry. It works really well with drones. In this case here, we're showing you the DJI and the Autel, and we've worked very closely with 12D model to make sure that all of our receivers work with 12D, but also tilt function as well. Here's a list of, like, we don't really have time to go into all the details of every single one of these, but as you can see here, the Emlids integrate really well with a huge range of related products in the drone, survey, and GIS domains. So now I'd like to introduce Sai. Sai's got a Bachelor of Engineering, Master's degree of Environmental Management, and Sai and the team were looking for a cost-effective way to get corrections for their DJI M350 and hyperspectral camera workflows. So I'll hand over to Sai to go through her case and introduce herself.
As Brad mentioned, I work with Nallawilli Bunjil, and today I'm here to share our journey from going from like a frustrating 10-meter error to survey grade accuracy, and how we managed to achieve this, all while also saying that I don't have any background in surveying. So yeah, before we get started, we're Nallawilli Bunjil. We're an Indigenous-led company, and we're also Supply Nation certified, and we work in remote sensing and analytics. We work in the space of LiDAR, photogrammetry, as well as hyperspectral, which is our new venture, and we do all of this through drone data capturing. And some of the use cases that we work on is land management and AI-based monitoring and conservation. So when we started off, we have our good old DJI drones, and we started off with the DJI RTK, thinking, hey, it's DJI, what could go wrong? And yeah, just when we were asking ourselves that question, we saw that everything could go wrong, because the DJI RTK had its own limitations. And once we processed all of our captures, we noticed that we had like a whopping 10-meter inaccuracy. And that was something we didn't expect to see with DJI RTK. And then we thought, okay, we really have to fix this, because we run detection models and AI models and a lot of machine learning algorithms. And in this case, spatial accuracy is something very important for our use case. And so we switched to the GNSS receiver, and we got the RS2 first. And we combine this with our hyperspectral data capture. So we use a head wall hyperspectral sensor camera, and we make sure that we're mapping every pixel to every type of species that we find on the ground, which we use for our species detection models, and also monitoring different types of species in peatlands. So that's why our spatial accuracy is very important to us. And when we use this, initially, we use this in RTK setup, and we still got our accuracy, and it was definitely way better than the DJI RTK setup. This is like some of the orthomosaics that we built using our hyperspectral cameras. And what we also realized was that when we're looking to expand and run these AI detection models, we also need to layer it with other kinds of data that we capture through LiDAR sensors, as well as photogrammetry that we use for labeling and identifying different species. So now that we have different types of data that we're overlaying on each other, we had to make sure that we had this centimeter level accuracy, which is when we brought this challenge to Brad, and Brad suggested that we switch over to a PPK methodology, or the post-processing kinematic. To post-processing kinematic, or like switching to PPK, was definitely a game changer for us, because we were able to take because we're doing all of this capture in very remote areas where like we barely get any kind of cellular reception. So what we could do was plug the GNSS receivers, and we had our rover collecting points, and we were receiving these corrections, and would make sure we were able to take this back to our office, where we had like our stable internet connection, we had like our computing power and everything. And since I'm someone who deals with everything post-processing and all of the analytics later, it made my life way easier. And as someone with like zero knowledge of surveying or anything, or any kind of field experience, in that matter. The Emlid app itself was very easy to use, and even the rovers and the base station setup was very easy because you had the app on hand, and it was something. And also because we have Indigenous and First Nations rangers who are handling these equipment, it has been quite easy for them to use, and it's very user friendly, and the app has also been great. So it's more like you just plug it in there and you have it logging your data, and then you can take it offline and work with this data. And so that's why Emlid really works for us, and we were able to integrate it into our workflow because it's easy to use, and if I can do it, I feel like anyone can do it. And also the workflow is very easy. So you just have it when you're capturing your data and it's logging your data, and then you export it to any format that is easy for you to use. For example, for our workflows, we're able to export this into our software that we use. We're using Metashape or QGIS or our hyperspectral workflows with Headwall. And we're able to integrate this data into any of that, or even POSPAC and so on. So this made this whole process very seamless and easy. And that way, yeah, we were able to switch from our 10-meter inaccuracy to get our centimeter level precision accuracy and in our geospatial data. And that now we're able to use these orthomosaics and all of these data to run AI detection models and machine learning models for monitoring and so on.
Cool. Okay. Well, let's move along to the next speaker, Martinez. Martinez works for Gold Coast City Council, and he's got some amazing results to share with us as well. So thanks, Marty.
Hello, everyone. Thank you, Brad, for introduction. My story probably wouldn't be as impressive as size. I'm a simple man, and I have just a simple story to tell. So my name is Martinez. Originally, I'm from Lithuania. I live in Australia over 7 years now. I travel all the world. Probably live more than in my own country now. I work at the Gold Coast City Council, and I'm a senior geospatial surveyor. What that means, I basically work mostly with laser scanners, and we do some analytical work. So my story is very simple. I said, how did I got my Emlid GPS, and how the story I'm just gonna briefly. So when we start working, originally we used to have, one of our instruments is Regal VZ400i. And as you can see, it uses a GPS antenna on top. And we use this, originally it came with a Leica GS16 GPS, and it was working, it was fine. And then suddenly one day we announced that 3G network is gonna be shut down. Unfortunately, that's an old instrument. All GPS, it doesn't have like what we do. I work for government. The budgets are very tight. You need to plan in advance. There's nowhere, I'm basically in the trouble. What I do now? And my friend just literally said, oh, why don't you try, the Emlid? It's a really good price, I was like, oh, really? Because, we quoted from Leica, all these good brands and stuff, and it's just really expensive. And I'm just, oh my gosh, we're not gonna find money where I'm gonna trouble. And then I just looked at Emlid and I just couldn't believe how cheap it is. I was like, what's the catch? It can't be right, What's the difference? I'm really thankful for Mangoesmapping, all this, that literally I just contact them. Look, I told my story and my problems. And I say, you know what? We'll send you an instrument, just test it out. And I'm like, really? That's great. So they sent me for a week. I tested out, I connected, it worked fine, no issues. As you can see, no cables required. We just use Bluetooth, which is even better than before. Accuracy works fine. I had more than a week, and what we do? Okay, let's try static. Let's try with my colleagues on 12D field. It worked and stuff. I'm just great. And what happened is, obviously I managed to get it because probably we just couldn't buy on credit card. The amount was so good that, we didn't have to go loops and request and all this. So it worked really, really well for me. And that's how I ended up with Emlid GPS. Obviously, the laser is a bit unique. We use it for the kinematic capture. What I do mostly works on the beaches. As you can see, as you may know, we had a bit of weather, unpredictable weather conditions, and it's really ruined our beaches. Beautiful, so we try to monitor and maintain them. So it's quite important to get them really good and accurate data, and quickly and often. What it does, so basically we use a kinematic scanning, and maybe I will explain a bit more how do I use them in this. So as you can see, we have an ATV setup. We have a scanner on top. Originally tried to use Emlid scan GPS, but then obviously it's a bit different technology, so we had to purchase Regal GPS antenna. And how they added up, and I'm just literally, okay, so I have a free GPS now in my back, in my car. I always keep with me. I don't have to share with my colleagues, not like, expensive GPS. We can't afford to have everyone, so they usually have to share. But because it's just basically almost like my personal now, and I just keep always in my car, in my this, and it's very compact, very light. So it works great for me. And how do I utilize it? Even if I capture data with a specified Regal equipment, I still use GPS. It's for my QA. Basically, when I do my scanning, all this, I need to make sure another data sources that it matches up or it's within the accuracy ranges we're looking after. Just a quick shots maybe in here what we do. Maybe I can actually change my screen. So yeah, this is one of the software as we're using Regal, and one of the projects we do, it's a Karambin. As you can see, it's quite a big area. We drive it and we capture it like in 40 minutes. As a QA working, sometimes we have a permanent buildings and structures which we can overlay and compare it. But if I do it first time, or I don't trust network, or I may have something issues, or where we come in locations where there's basically not really much of surfaces or structures I can pick up, that's where it comes really handy, that GPS. I just come out of ATV afterwards and I do my profile lines, and then I compare both two different data sets. One come from GPS, one come from other equipment. I'm just looking if there's no errors, so we get really good results. So it works really well for me. Another bigger screen as well, which is another project we're working on, that's actually from the surface paradise all the way goes to the spit. And it's just great. We extract it, we get the surfaces, we get the DEMs, and that's where all the calculations of the volumes, how the sand moves. Switch off. Bit laggy. Yeah. As you can see, the benefit with point cloud, you can capture a lot of data very quickly, but the downside, it picks up a lot of unnecessary things, people, noises, and then you can clean out. But the final product is actually the DEM or surfaces, and that's what it's using for volume calculations, sand movement, cut profiles, and the rest of it. And that's how we utilize point cloud data. Is actually can do more than that. It can be for other structures, and so it's very useful. We have a very quick method to capture, accurate, and deliveries. And as I said, Emlid originally worked me as a GPS on the scanner, which I used to do static scans, but then we started using a bit more kinematic or mobilizer scanning, which is even better, and I still find uses with it. It's not only one use cases I can think about it, because obviously when I got this, all my colleagues started noticing, oh, what is this? How do you use it? And I just quickly show it and stuff. And as I said, one of the projects I could quickly speak about or tell about my story, how it really, really worked well. It's a construction site at Karambin seawall. That's the project we just scanned and I showed it use. So basically it was a construction site, and we have a foreman and construction there where they were building a rock wall, and they had to set it out and check the elevations against the model surfaces. The requirement was 300 mil accuracy, which is way more than GPS can achieve than that. And I was like, oh, I can get you like 20 mil, 30 mil, 10 times better than you expect. And we were like, oh wow. The problem was always, because either you had to have a surveyor on site full time where they put some stones and then he goes, measures, and then checks and all this, which was sometimes a bit annoying because we had other sites, we have limited resources with people, you arrange, you come there, maybe they're not ready and stuff. So, and I was like, my colleague says, why? I said, why don't you buy this GPS? So cheap. It's gonna pay off in you a couple of weeks, the way you're spending on us and stuff. And I just showed them how to use it with their phone. You just connect it. And the best part of it really, I like the web app. For me, it's the best feature of it because what it gives us, we literally upload drawings, thin surfaces online, and they just, oh, that's the project I send you, use this project. He goes in and he knows that how to set out. It's very easy to use, and they can do set out themselves and compare the levels and accuracies, and they can just work around it. So for us, worked really well. And more colleagues starting noticing. I know different departments starting looking into this GPS because it's just, for GIS data capture and stuff. It just works for the fraction of the price we used to, pay and stuff. And I'm gladly, like, personally, the money we spent it was reliable, and I'm just loving it. So that's why I'm glad to share my story. I'm not get paid to advertise. I think Brett already did that good job on this, but I'm just thought, like, I can share my story, and that's what it is. Quick features, what I think about this from perspective of a surveyor, maybe. Obviously, we're comparing to expensive GPS units. I can tell the price because it's reflection, but it's probably 7 times more, 8 times maybe more than you buy it. When you buy equipment, yes, it's good, but it comes with a proprietary batteries, which means like only special batteries you need to purchase from them. You can't reuse them. They're quite expensive, stuff. Same with cables, chargers. You have to use a special logger when it comes up, pay licenses, subscriptions, and all stuff, which is another cost on top of that. And it's actually quite difficult to justify or buy it and all stuff. With this one, it's so simple to use, very intuitive. I think that, as I told you, I showed to no surveyors or people, engineers, foremen, construction guys and stuff. And it was so easy for them to use that. It quickly picked up and there's no issues. Obviously, I really like it. Maybe it's not at the beginning was not rich in features. As I said, that more expensive equipment comes up with way more functionality and all this. But what is really good that it's very rapidly developed, new features introduce it. And actually, you can make a request and they look at it and they're actually going to introduce that request, which is really great. That's what I found it really good because it's rare to find where, you get what you get. There's no, people don't listen to you because everyone's using a bit differently or have some features to use it. And so far, my experience was like really good. As I said, the feature we actually looked at it where you can stake to the thin surface. That's exactly what we used for, and it just worked perfectly. And it was just like, wow, it just came week before we actually needed to use it. And I was like, wow, that's perfect. And that's why it worked for those construction guys really well. And as I said, the most appreciated feature is web app. We can sync it. We can download. I can actually look at how they lively pick up points, which is really good. SD cards or something, the data wouldn't be lost because it's a backup as well. And as I said, you can export in a couple of formats, which very uniform and use in different softwares and all this. Just to conclusion as quickly, I think that GPS is one of the essential equipment tools in surveying, and the Emlid RS3 is just great for value of money, not only for surveyors, but for a broader spectrum of professionals, engineers, foremen, construction works. And to be honest, even a random person can buy it and just start picking up points and stuff as a hobby. It's just great tool. And as I said, for the price, the range of the price that it guesses, it just enables to use that accurate data, which is great for engineering and anything. So as I said, my story is quite short. I don't use as much maybe as I would love to, but I still find the ways to utilize it. And I always keep it with me. It's a very small, compact thing. I take it. Sometimes I need to find a PM, permanent marker or something, and they're usually covered or something. I don't know. I just pop up quickly, put the coordinates, and just take out and just finds me location. Same, very many use cases you can find out because GPS is such a useful tool. And as I said before, you couldn't afford it. You couldn't think about it. That you could maybe buy these toy ones as well, but for the price where you get you 20 mil accuracy, to even 1 centimeter sometimes, if you use the base and close and stuff, that's just amazing. And as I said, so many use cases you can think about it. And it's just great. As I said, I'm really happy with my product. I'm happy with and the service is great as well. It's a bit hard to find a good service in Australia, but so far my experience was very good. I hope they're going to keep up with that. So yeah, thank you.
All right, we won't wrap it up. I think that was a really great webinar, and thank you so much to Martinez and Sai for coming along and doing your presentation. It's valuable for us always to have people like yourself to come along and show us how you love the equipment and share that interest with everybody else. Here's my details again, just in case you'd like to keep in touch. Give me a call, email, LinkedIn. I'm on Facebook as well, somewhat on Instagram, but not so much. Thank you, everybody, and be looking forward to seeing you all soon. We'll be doing this again very shortly. Thanks, everyone.